All right, let's get right into it. We all know AI is ridiculously powerful, right? But what if I told you there's a hidden vulnerability, a kind of secret backdoor that's causing some of the most advanced AI systems to fail, and fail in a big way? And it's probably not for the reason you think.
So how big of a failure are we talking about? Get this, some of the most complex agentic AIs out there, the ones designed to do complicated multi-step jobs, are failing up to 90% of the time. 90. That is just an absolutely mind-boggling failure rate.
So that begs the big question, the one we're going to dig into right now. What on earth is making these super smart systems so incredibly fragile? Well, it turns out the answer is hiding in the very thing that's supposed to make them so intelligent in the first place.
And that thing has a name: context engineering. Now, the easiest way to think about it is like this. If the AI model is a high-performance engine, then context is its fuel. It's all that real-world data, like product manuals, company policies, old support tickets, that the AI needs to give a useful, accurate answer instead of just, making stuff up. Context is what makes an AI reliable.
But, and this is a huge but, here's the twist. That same fuel that makes the AI so powerful, it also creates a brand new and really dangerous playground for hackers. Because if you can poison the fuel, well, you can hijack the entire engine.
And look, this isn't some sci-fi theory about the future. This is happening right now. Attackers are already in this playground, and they're actively figuring out how to weaponize an AI's context. Let's take a look at how this is playing out.
We've seen things escalate fast. It started with stuff that was kind of funny, right? Like the Chevy chatbot incident back in late 2023, where someone tricked it into offering a brand new car for $1. But by 2025, the stakes got way, way higher. We're talking about GitLab's AI being manipulated to leak private source code, and a huge attack targeting Amazon's developer assistant.
Let's really zoom in on that Amazon Q attack, because it's the perfect chilling example. The goal wasn't just to trick it, it was terrifyingly simple: to turn a helpful coding assistant into a destructive weapon that would attack its own user.
Now, check this out. This quote on the screen, that's not a summary. That's part of the actual malicious prompt attackers used. They didn't have to write a single line of code. They just told the AI as part of its instructions to start deleting everything it had access to. Luckily, a syntax error actually stopped the attack. But whoa, the vulnerability was put on full display for everyone to see.
And this just perfectly highlights the common thread here. In all these attacks, no code was hacked. No AI models were breached. The attackers simply understood how the AI thinks, and they spoke its language. They twisted the very context, the very data that the AI was built to trust. So, what does this all mean? It means our old security models, they're not going to cut it. We need a totally new way of thinking to defend against this. It is time for security to evolve. It's time to shift up.
For decades, cybersecurity has all been about shift left. Find bugs in the code before you ship it. But that's not enough anymore. This new idea, shift up, changes the focus to the entire AI system, that whole abstraction layer. It's not just about the code, it's about securing the prompts, the data pipelines, and the business logic that tell the AI how to behave.
So to put it simply, shift up just means we have to expand our security perimeter. We got to move beyond just the code and start protecting the entire system that allows an AI to think and act. And that means, above all else, protecting its context.
Okay, so the concept makes sense, but how do you actually do it? What are the practical steps? Well, let's walk through the defensive playbook for locking down this new, absolutely critical context layer.
First things first, you have to understand the logic. You've got to map out exactly how and where context gets into your system and how it influences the AI's decisions. Next, you have to sanitize and classify that context, strip out sensitive data, and clearly label what's a trusted source and what isn't. Step 3 is all about access control. Use secure data pipelines and role-based permissions just like you would for any other critical part of your infrastructure. Fourth, you have to audit and monitor everything. Track all the changes, log who's accessing what so you can spot weird behavior fast. And finally, you apply policy orchestration. Think of it as a security guard that stands between the context and the AI, filtering everything in real time.
Look, if you remember just one thing from all this, make it this. You have got to start treating your AI's context with the exact same level of seriousness and discipline as you treat your production code. It's not just passive data anymore. It's an active, logical part of your application.
Because at the end of the day, that's what it all comes down to. You can build the most powerful, most amazing AI in the world,
But if its context isn't secure, you can't ever really trust it. Secure context is the absolute cornerstone of trustworthy AI, period.
And that really leaves us with one last question. A question you should ask about any AI system you build or use from now on. Is it just performing tasks based on whatever it's fed? Or have you actually done the work to make it genuinely trustworthy? Because that difference, that could be everything.